Okay. Good evening. Can you hear me? Sorry. Good evening. Okay. Good. Okay. Last week, before that, next next week mean the final 31st, 31st of March. 31st of March, you will have your fourth exam number 4. Exam number 4. I'll send a list of the order of the paper into your group. Then you can ready. It's a 4-hour paper. 4-hour paper. 4-hour paper. I'll send you the order of what's the pattern of the paper. And you this paper you have 50 MCQ questions. It's a complete paper. 50 MCQ questions and 2 structured essay and 3 essay questions. You have to answer for all questions. It's a good exam paper. Actually, it is the collection of model paper questions. The collection of model paper questions. Okay. Last week, we discussed about the heat energy. Heat energy. What's the meaning of the heat expansion, contraction, and what are the types of heat expansion? What are the solid expansion types, liquid expansion types, gas expansion types? What's the meaning of the volume expansion, right? Apparent expansion and real volume expansion and apparent volume expansion, everything, every parts we discussed. Okay. Today, we are going to final part of the heat lesson. Do you remember in theory class, the heat lesson we can divide into 3 main areas, no? Heat lesson. Heat lesson we can divide into 3 main areas. Heat lesson. What are the areas? The first one, the heat expansion or thermal expansion. The thermal expansion part we already discussed. Thermal expansion. Thermal expansion part we already discussed, and all type of questions discussed. Today also we are doing some part of thermal expansion questions. Okay, the second part is a quantity of heat Q. Quantity of heat. In quantity of heat, we mainly discussing heat capacity, specific heat capacity, and specific latent heat. Last week class, I separately introduced what is the heat capacity and what is the specific heat capacity and what is the specific latent heat, and physical state changes. Physical state changes and what are the difference and how we need to use these different measurements in different questions. No? Everything we discussed. Quantity of heat. In quantity of heat, we mainly discussing about heat capacity, specific heat capacity, and specific latent heat. Okay, this is our third. This is the most important part. Today, our target more focus into our final part and complete the heat lesson revise sessions. In the final part of the heat lesson, it is thermal transportation. Thermal transportation or heat transformation. Heat transformation or thermal transformation or transportation. Okay. Do you remember what's the meaning of the thermal transformation? Heat transformation, thermal transformation. Thermal transformation. Definition. Thermal transformation. Definition. Yeah. Remember, Samya? Thermal transformation. Thermal transformation. Transferring, actually. That's a mean. But, Fatima? Thermal transformation or heat transformation. Kabir? Yeah, very good. Others? What's the meaning of thermal transformation? Yeah, very good. Very good, Rehla. Very good, Kabir. The heat energy transfer from one point to another point. Very good. The heat energy transfer from one point to another point. Normally, if you got the temperature difference, is it moving high temperature to low or low temperature to high? What do you think? High to low or low to high? This side or this side? Basics. High to low or low to high? Fatima? The heat energy always transfer from high temperature to low temperature or low temperature to high temperature. Very good. It is always transfer from high to low. High to low, not low to high. It is transfer from high temperature to low temperature. That's why the heat is an energy type. Heat is an energy type. Thermal energy is a type of energy which is formed due to temperature difference. Do you remember? That's the definition of heat energy. These definitions very important in heat lesson. All definitions you have to remember. The thermal transformation or heat transformation means thermal energy or heat energy transfer from one point to another point. One point to another point. Okay. In lesson, I explained three main thermal transformation methods. What are the types? Three main thermal transformation methods. What are the types? Conduction, conduction, convection, conduction, convection. What is the final one? Radiation. Very good. Radiation. Okay. We have three main thermal transformation methods. What are the types? Conduction, convection, and radiation. Okay, do you remember? I will explain the simple idea. What's the meaning of conduction? What's the meaning of the conduction? You have to revise again because this is the end of March. Your exam date is fixed now. What's the exam date? 10th of August. 10th of August. Approximate හරියටම තව 100 days වගේ තියෙන. Okay, therefore now actually now all of me then අපිට what are the lessons we have to cover? Fluid mechanism, industry chemistry, natural products, and polymers and environment chemistry. We have only 5 lessons and we have completed more than 17 lessons now. I'll send you what are the completed lesson and how you then you can ready for your exam end of this week. No, next Tuesday. Next Tuesday you have exam. Okay, now the thing is revise again and again, discuss lessons. අපි කරපුවාම ආයි revise කරන එක තමයි කරන්න ඕන. Okay, now this is your final 100 day. This is your final 100 day. If you need good result, now as I told last day, the balance your three subject is very important. That means you have to work all three subjects in balance. If not, it will be trouble in final few days, final 2 weeks. You will be trouble in final final 10 days, or final week. Okay, therefore, if you think if you have any difficult part in ICT or somewhere, then you have to get additional time. For particular period, you can get additional time for this subject. Okay, likewise, you have to balance and keep same level working pattern for all subjects, all three subjects. That's the thing. This final 100 days. Right. Now we have three main thermal conduction thermal transformation methods. Okay, what's the meaning of conduction? Mainly, I told the conduction is the heat transfer to conduction by solid objects, no? Solid objects. What's the reason? What is the reason and how heat transfer through solid objects? How to transfer through solid objects? It is like this. You know, solid molecule structure. Solids molecule structure, they are highly compacted, no? Molecules are highly compacted. Molecule highly compacted mean, okay, they are highly compacted like this. And they have very strong intermolecule bonds. Intermolecule bonds mean bond between molecules. They have very strong intermolecule bonds like this. Okay. Now what's the meaning of the conduction? If I heat one end of this rod, solid rod, if we heat the one end of this metal rod, what happens? This nearest molecule absorb heat and their molecule kinetic energy, vibration increasing. Due to and heated and vibration increase. Vibration increasing. Molecule kinetic energy is increasing. Due to this vibration, what happens? It is collide with other nearest molecules. Then part of heat energy transfer to nearest molecule. That's likewise molecule to molecule. Then again this nearest molecule absorb heat and increase their energy level and increase vibration, and again molecule to molecule heat transformation method we called as a conduction. Understood? Molecule to molecule. No any net molecule movements. That means molecule in the same place, not molecule movements, only molecule vibrate, and molecule to molecule thermal transformation we called as thermal conduction. Understood? Matakai? Thermal conduction. The thing you need to remember in conduction, no any net molecule movement. Net molecule movement means molecules not moving with heat. It is not the heat conduction. In heat conduction, molecules only vibrate. Molecule in the same place and vibrate. Due to collision, molecule to molecule heat energy transfer, not molecule transfer. Remember, Tanya? Molecule to molecule collision and heat transformation we called as a conduction. Okay, what's the meaning of the convection? Conduction, I told the conduction always take place for solid objects. Solid mean. If you got liquid and gases, mainly main heat transfer method for fluid, mainly liquid and gas both we called as fluid, it is convection. It is convection. Okay, how to heat transfer by convection through liquid and gas both fluid media. Fluid media through fluid media, how to transfer heat? How to transfer heat? Okay, this is a convection. This is a convection. Okay, if you got convection for liquid, convection through liquid, think a simple example, boiling water in your gas cooker or whatever heating pan. Okay, now this is a heating source, and this is a water. You know, water molecules are, they closely packed, but it is not compacted like solid. They are close, they are medium level intermolecule bonds, no? Medium intermolecule bonds and not compacted like solid. Okay, they are the liquid molecules. Liquid molecules. Now what happened? When I provide heat source, this heat energy absorbed by molecule, lower level molecule, bottom molecule, and what happened? Their temperature increasing the temperature of this molecule, and density what happened? Decreasing. Temperature and density always they have inverse proportion, inverse relationship. Therefore, temperature increasing, the density is decreasing. Density decreasing, what happened? But if we compare upper molecules, what happened? Their temperature comparatively low, therefore high density molecules. Now what happened? High density molecule in this container going down and low density molecules always going up. The circulating process, due to temperature difference and density difference, molecules heat transfer by molecule circumference, molecule circulate, we called as a convection. Understood? Due to this temperature difference, molecule temperature difference, it's coming density difference between molecules. Due to this density difference, heat energy transfer by molecule circulating, that we called as convection. What's the main difference between conduction and convection? In conduction, no any molecule net moments, no, only molecules in the same place and vibrate, molecule to molecule heat transformation. But in convection, you can see molecule has net movements, heat transfer to molecules. See, this absorb heat energy transfer by as it is molecule එකත් එක්කම තමයි transfer වෙන්නේ. Understood? දෙහිනි? Okay. Now I told to liquid and gas, both fluids, both liquid and gas, both we called as fluid. Okay, last week I explained what's the definition of fluids. What's the definition of fluid, Tanya? Fluids කියන්නේ මොනවද? Liquid and gas, both fluids. Then what's the definition of fluids? Last week I explained. Any substance or material with which property? Which property, Tanya? Which property? Fatima? Fluids mean? Substance with which property? flowing ability, yes, or viscosity. Viscosity, the flowing ability we called as viscosity. Remember, remember. Now let's see how to convection, how to transfer heat to gases by convection. Now this is a method of heat thermal transformation through liquids. The same method for gas as well, in our atmosphere as well. In our atmosphere as well. See, normally think it is a sea level, sea surface. This is a sea surface or whatever water surface. Water surface. Now in daytime, what happened? In daytime, due to sunlight, the water surface is heating. The water surface heating. The water surface heating. Water surface heating, then start to evaporate water vapor. Start to evaporate water vapor. They are the water vapor. These green color dots are the water vapor now. Okay. They are the water vapor. They are the water vapor. Now, how about the temperature of these? Now, they are water vapors. Now, it is gas form. It is water vapor now. It is gas form, water vapor, H2O gas. Now, how about their temperature? They are highly heated because evaporated molecules, they are highly heated. Now, what happened to the density of this molecule is the density is low. But comparatively, the water vapor in upper atmosphere, what happened? Water vapor and other gas molecules, comparatively, their temperature is low. But therefore, they high density comparatively. Yeah, comparatively, they are high. The density of this upper molecule is greater than this evaporated water molecules. Now what happened? These gas molecules, high density gas molecules going down and low density water molecules going up. Then what happened? Again, the same thing. Again, same thing. Again, same thing. That is a method. Water vapor going to upper atmosphere. Okay, sorry. Okay, can you hear me? Okay. There's a connection issue. I think now okay. Send me message. Joel. Har. Okay. Today lesson very important. I am going to explain. Yeah. Now I am host. Har. Okay. Today we are discussing very important part. The thermal transformation methods. I'm going to explain the full details, full theory part. Revise again. Hari. Okay, do you know in Sri Lanka, November, December, not November, December, October, November, October, November, October, November, March, April has a special rain type that we call as convection rain or intermonsoon rain or convection rain. The convection rain is formed due to this convection process, this gas water molecule, water vapors going to upper atmosphere by convection due to density difference and temperature difference. Understood? Normally, do you know in April, March and April, always rain evening time? No? Then May, March ne? Next month වගේ වෙද්දි මොන වෙලාවටද වහින්නේ? Kabir? Normally, what's the raining time? Do you have noticed that? Normally April, the May, nang dry period ni still. Now in Sri Lanka, in final lesson we can discuss in not only Sri Lanka, entire world due to human activities and other reasons, they have world has climate changes. Due to that, all raining patterns and everything, wind patterns, everything has been changed now. Yeah, evening time, the convectional rain, yes. Convectional rains or that we call as intermonsoon rains. This type rains coming between two monsoon, between normally the northwest monsoon come finish February. Harinang end of February ඉවර වෙන්න ඕන. But still northwest monsoon තමයි යන්නේ. තාම convectional rain start වෙලා නැහැ. The reason climate changes. Climate changes. Okay, that's about convection. Okay, what are the media? Through liquids or through gases? Liquid or gases, convection. That's a thermal transformation method. Through liquid or gases, it is convection. What's the thermal transformation method through solid? It is always conduction. It's always conduction. Molecule to molecule. But in convection, it is transfer with net molecule movement, right? It has a net molecule movement. Here, it transfer with molecule. Molecule එකත් move වෙනවා. Molecule එකත් move වෙනවා. හරි. That's conduction and convection. Okay, the final one. What is the final thermal transformation method? Radiation. Okay, I told the conduction through solid objects, solid material. Convection through liquid and gas material. Then radiation. What's the media? Tanya, what's the medium for radiation? For radiation? Sarmia? Now answer. Now we already discussed these things in the lesson. Yeah, without the media. Very good. The radiation transfer heat without any media. It is a special case because now solid, liquid, and gas, all substance material types we discussed. To solid, always conduction, liquid and gases, thermal transformation method is convection. The radiation is a special case. It is not using without media. The thermal transform without media as which rays? As without media. Sorry. Without media, without media as EM waves. EM waves mean electromagnetic waves. Yes, very good, Trela. Electromagnetic waves, EM waves in short form. Using EM waves. EM waves. EM waves. What are the examples? The thermal transformation from sun to earth by using electromagnetic waves. In our atmosphere, normally the sun to earth thermal transformation to our atmosphere, lot of gas particles, air particles, but in radiation, even this environment, even this surrounding has air particles. They only use electromagnetic energy. They're not going to use this electromagnetic wave, not use this air particles. Media ekak use karanne. Okay, that's why we call it is a radiation. Okay, if you got fire, අපි ගිනි ගොඩක් ගත්තොත් the heat transfer to surrounding, right? What's the transformation method? Radiation. Radiation is a method. Normally, radiation, then how we can define the radiation mean? Transfer heat without any media as electromagnetic waves. Transfer heat without any media. Transfer heat without using any media as electromagnetic waves, as EM waves. EM waves. EM waves. EM waves. EM waves. Okay. And I told if it is radiation, the two substance should have considerable temperature difference, right? එයාලගේ තියෙන්න ඕන considerable temperature difference එක. Considerable temperature difference, it's important to radiation to transfer electromagnetic waves. To transfer electromagnetic waves. Hi. Okay, that's a thermal transformation full theory part. Full theory part. Full theory part. Hi. And finally, I told these electromagnetic waves, if it is black or rough surfaces, it is highly absorption. High absorption. The reflection is very low. The reflection is very low. But if you got the white color and smooth surface, like this white color and smooth surfaces, what happened? Normally school uniforms, highly reflected, high EM waves, highly reflected, very less absorption. Therefore, if you going to play cricket or whatever outdoor activities, better to dress with white color. No? Then you can reduce your body temperature. Because a lot of electromagnetic waves, what happen? Reflecting. Absorption very low. But if you use black or brown or dark color dress, what happen? The reflection very low. All absorbing. Then what happen? Due to absorbing, your body temperature will be increasing and it is very difficult to you. Hi. Remember, okay. Remember. They always ask. Hi. That is a thermal transformation full theory parts. And finally, we have in this lesson calculation part. Okay, before go to paper, I will explain this part as well. This is a very simple part. The thermal conduction rate. Okay, actually We have three thermal transformation methods, no? Conduction, convection, and radiation. We can get thermal conduction rate, thermal convection rate, thermal radiation rate. All we can calculate, but in our syllabus, we only calculate thermal conduction rate. Thermal conduction rate විතරයි අපිට තියෙන්නේ. Thermal conduction rate. Thermal conduction rate or rate of thermal conduction. Thermal conduction rate. Thermal conduction rate within bracket Q over T. Okay, do you remember what's the meaning of the thermal conduction rate? Thermal conduction rate. Thermal conduction rate. What's the meaning of the thermal conduction rate? Amina? Amin absent. What's the meaning of the thermal conduction rate or rate of thermal conduction? Yeah, very simple. It's physics, no? Yeah, very good. The amount of heat transfer, by any point on any solid object in a unit time, or in short form, the amount of heat transfer, the amount of heat energy transfer to unit time, or the amount of heat energy conducted within unit time. Within unit time, very good. The amount of heat energy, the heat energy conducted means transferred within 1 second, within 1 second. Okay, remember that is a thermal conduction rate. Therefore, we can say the thermal conduction rate, in short form TCR, thermal conduction rate equal the conducted heat energy, the conducted heat energy means Q, right? Energy, quantity of heat divided by time. The conducted heat energy divided by time. The time taken to heat transformation, right? That we call as T. That's why I told the thermal conduction rate equal to the Q over T. The amount of heat transfer to unit time. The amount of heat transfer per unit time. The amount of heat transfer per unit time. Remember? Rehlan? Hari? Rehlan? Clear? That's the meaning of the thermal conduction rate. The amount of heat conducted within unit time. Now, do you have any doubt up to now, Samia? Joel, up to now, okay? Okay, next point. Okay, I explain how many factors affect on the thermal conduction rate. How many factors? That was exam question. Kabir, how many factors affect on thermal conduction rate? Oh, Fatima, how many factors affect on thermal conduction rate? How many factors affect on thermal conduction rate? Very good. 4 factors. Okay. Matak karaga? What are the factors? What are the factors? The first one, the length of the solid object, length of the solid rod, length, L. What's the second one? Cross section area. Good. Cross section area, not the area, cross section area. Cross section area. Cross section area. Cross section area, capital A. Capital A. What else? What else? What else? Temperature difference. Temperature difference. Temperature difference. Delta theta. Delta theta. Fourth one, final one, material type. Very good. Substance type. Substance type. Okay. They are the factors. There are 4 main factors affect on thermal conduction rate. Thermal conduction rate. There are 4 main factors affect on thermal conduction rate. What are the factors? Length, cross section area, temperature difference, and material or substance type. Okay, that was the exam question. What are the factors? Length, cross section area, temperature difference, or material type. Okay, I told length increasing. Length increasing. What happened to the thermal conduction rate? It's decreasing because it's too long path. No, when increase the length එක වැඩි disturbing වැඩි when increase the length. Okay, therefore, when increase the length, thermal conduction rate decreasing. Therefore, we can say the thermal conduction rate inversely delta, sorry, Q bedima T inversely proportional to the L. No, this is my first equation because it is inverse proportional. Inverse proportional. Why? Length increasing, the thermal conduction rate decreasing. More disturbed when increase the length. When increase the length. But when increase the cross section area, what happened? Then it's easy path to transfer heat when increase the cross section area. No, easy to transfer. Therefore, it is directly proportional. Q by T directly proportional to the A. That's my second equation. Q by T directly proportional to cross section area. Okay, when increase the temperature difference, ECD, the thermal conduction rate is greater. Normally, Q over T directly proportional to temperature difference as well, delta theta as well. Okay, likewise, we have 3 relationships now. We have 3 relationships. Okay, according to these relationships, using these relationships, I can get very important equation, Q over T is directly proportional to L1, sorry, Q over T directly proportional to A delta theta into 1 over L. 1 over L. Okay. Now to remove this proportional mark, Q over T equal K. The K is a constant. I told always if you remove this proportional mark and replace into equal, we have to use constant. Q of T equal KA into delta theta multiplied by 1 delta theta divided by L. This is our final equation to calculate thermal conduction rate. Thermal conduction rate. Hari. Then, what's the meaning of the A? Very important. That was exam question. That's why I asked. What's the name of the A? What's the name of the A? Pehlan? Cross-section area. Cross-section area. Very good. What's the name of the delta theta? What's the name of delta theta? Temperature difference. Final temperature minus initial, or large value minus small value. Okay. L mean length. L length. Okay, if you get Q over T as a one term, it is thermal conduction rate. If you got separately, the Q is the conducted heat amount. The T is the time consumption. Okay, now what is the name of K? Can anyone send me? What's the name of K? Tanya? What's the name of K? What's the name of K? Jihini? What's the name of K? What's the name of K? No, Tanya. Yeah, it is depend on the substance type, but it has a special name. Thermal conductivity, very good. The K is a thermal conductivity. Yeah, thermal conductivity is a hari, but it has a special name, Tanya. Then, if there was question and write down the thermal conduction rate equation and label terms, you can't say K is substance type. Yeah, K depend on the substance type. That okay. When change the substance type, as example, copper has a special value. When it is aluminium, it has another value for K. But it is not the substance type. It is thermal conductivity. Thermal conductivity. The thermal conductivity is the name. Thermal conductivity. That's a K. The thermal conductivity is a factor that is dependent on the material type. That's correct. When change the material type, the value is specific to material. Specific to material type. Material to material, that will be changed. That's okay, but you have to remember this now. Thermal conductivity. Do you remember what's the unit of the thermal conductivity? Unit of the thermal conductivity? Matakai? Kabir? The unit of thermal conductivity? The unit of thermal conductivity? Fatima? Very good. What per meter per Kelvin? 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 Huh. Okay, that's the end of theory part. And I forgot one thing. Okay, if you got this part separately mean delta theta over L. Final point. If you got delta theta over L, delta theta over L, that we called by a special name. Do you remember this name? Temperature difference in a unit length. That's the meaning. Temperature difference of a unit length of solid object that we called as a special name. Temperature gradient. Temperature gradient. Temperature gradient. Temperature gradient. Temperature gradient. Okay, that's I think third time I am doing this part. Okay, now again you can't forget these things. Hurry. Temperature gradient mean what's the definition? Do you need to remember? Do you need to by heart? No. The temperature difference per unit length. That's the temperature gradient. What's the equation? Temperature gradient delta theta over L. Delta theta over L. Delta theta over L. Delta theta over L. Okay. Go to today's paper. Okay, this area volume question, that is 2018 past paper question. Okay, I think 17. No? Yeah, I can't remember 2008, 17 or 18. That was a past paper question. That's a this heat question is a model paper question. Okay, first let's discuss this heat question. Okay, write down the name of two physical quantities Q over T and Q minus, sorry, it is mistake, not Q minus Q1 minus Qt, it should be theta 1 minus theta 2. Theta 1 minus theta 2. Theta 1 minus theta 2. Theta this correct this theta 1 minus theta 2 divide by d. Divide by d. Hard. Write down the name of two physical quantities Q over T. What's the meaning of Q over T? Now I explain. Q over T. What's the name of Q over T? Thermal conduction rate. Thermal conduction rate. Q over T thermal conduction rate. Theta 2 minus theta 1 mean temperature difference divided by length or distance. It is temperature gradient. Temperature gradient. Temperature gradient. And very simple. Okay, first part Q over T thermal conduction rate and temperature difference divided by length or distance, that is temperature gradient. Temperature gradient. Second one, write the equation for thermal conductivity rate involved in the above coefficient. Now you know Q over T equal Ka delta theta over L. Delta theta over L. In an air conditioned computer lab, the inside temperature is 20 Celsius and the outside temperature is 30 Celsius. On a wall of 5 meter long, 5 meter long, 2 meter height, 2 meter height and 20 centimeter thickness, conduct heat into the room. Find the thermal conductivity rate to the wall if the thermal conductivity of the material which the wall is made for what per meter per Kelvin. What per meter per Kelvin. හරි කොහොමද කරන්නේ? Anyone got this answer? කවුරු හරි ගත්තද මේක? කබීර්, තානියා, සල්මියා. What's the answer? හරි. හදමු ඉක්මනට හදුවේ නැත්තම්. දෙහිනි? Fatima, do you complete? Okay, very simple. All data given. First of all, easily you can understand this type of question if you can draw a figure like this. An air conditioned computer lab, the inside temperature 20 Celsius. Now think this is the container, this is the wall of this container. This is the wall of this computer lab. This is a wall. This is the wall of this computer lab. This is a wall. Now it has a thickness, no? The wall has small thickness 20 centimeter. This is the wall. The outside temperature, sorry, the inside temperature 20 Celsius and the outside temperature 30 Celsius. I think sorry. Now it is 5 meter length, 2 meter height and 20 centimeter thickness. And outside temperature, this is outside, the outside temperature 30 Celsius due to air conditioner, inside temperature 20 Celsius. 20 Celsius. Now the question asks, find the thermal conduction rate to the wall if the thermal conductivity of the wall is given. Thermal conductivity of the wall, K. Thermal conductivity means K, right? K. It is K equal 4 watt per meter per Kelvin. Watt per meter per Kelvin. Hi. Okay. Now, what's your method? Now tell me that heat conducting outside to inside to outside. What do you think? This is the outside. This is the outside. This is the inside. Tell me the heat transfer outside to inside to outside. Tanya. Outside to inside to outside. Yeah, out to in. Very good. Why? The heat transfer from high temperature to low temperature. Out to in. Therefore, I will mark it as like this. Mark it's out to in. Out to in. Heat transfer out to in. Then you can use basic equation Q over T equal Ka delta theta over time. Delta theta over time. Q over T is a thermal conduction rate. This is asking, right? The K value given 4. What? M minus 1, K minus 1. What? M minus 1, K minus 1. What's the cross section area now? This is a cross section, right? This is a cross section. 5 into 2, it is 10 square meter. 10 square meter. 10 square meter. Sorry, it is not TL. No? What's the temperature difference? Only 10. 30 minus 20, 10. The length. Okay. ගොඩක් අය මේක වරද්දනවා. length කිව්වම wall එකේ length එක දානවා. Heat transfer through wall or it's a cross section through thickness. The heat transfer to thickness inside to outside. Then it is only 2 centimeter. 2 centimeter or 20 centimeter. No? Yeah, 20 centimeter is the thickness. The wall එක මෙහෙම wall එක තියෙනවා. The heat transfer through outside to inside through the thickness, not through this length direction. මෙහෙම heat එක යන්නේ. එහෙම තමයි. 20 centimeter. 20 centimeter. 20 centimeter mean it's Kelvin. 20 centimeter means 0.2 meter. Now, meter to meter square cancel out. Meter m minus 1 to meter cancel out. K minus 1 to K cancel out. 4 into 10. 4 into 10, it is 40. 40 into 10 again 400. 400 over 0.2, it is 4000 over 2, it is 2000, right? 2000 watt. Please correct this. Good. Others? Very simple. Tanya? Sarmia? Fatima? Dini? Next, this one is the most important question. This one is the most important question. Now, previously only one layer of wall. Now it has two walls. Well, to increase the energy efficiency of the laboratory, 1 centimeter wooden layer was connected to the inside of the wall. Inside of the wall, it's connecting inside. Now this is the inside, no? This is the inside. It's connecting wooden layer. Wooden layer. Connecting a wooden layer. Like this. Wooden layer, 5 centimeter thickness, wooden layer connected to this wall. 5 centimeter is the thickness. 5 centimeter thick. Wooden layer connected to inside, not outside, inside. Hi. Maybe. Next. Calculate the temperature of the intersurface of the wall and wooden layer. Yeah, wall and wooden layer if it is transfer heat continuously. Okay, do you know what's the meaning of the continuous heat transformation? In continuous stage, or that we called as steady state. Steady. Velavadi. Or continuous state. Do you know what's the meaning? Khabe. Do you know what's the meaning of steady or continuous state? Heat transfer in continuous way. What's the meaning? Continuous. That means the amount of heat absorbed. That's the meaning actually. I will explain the steady for steady condition for rod. Okay, if you got rod like this, the steady state or continuous state mean the amount of heat enter within the amount of heat enter within 1 second. Think 1 second 5 joule enter to this 5 joule enter to this rod. Within same time 1 second 5 joule leaving out. මෙහෙන් එන එක මෙහෙන් leave වෙන එකට equal. That we called as a continuous stage. Okay, that's the meaning of continuous stage. The entering heat amount in a uniform in a particular time, it is equal to the leaving out in the same time level, in the same time. Now How to calculate the intersurface temperature? The theta is asking. Think this is the intersurface temperature. This is the intersurface temperature. Okay, if you want more clear diagram, I will draw like this. I'll draw like this. More clear diagram. Okay, this is the wall now. Wall. 20 centimeter thickness. This is the inside, this is outside. In inside, 5 centimeter, another wooden block now. It's a cross section of the wall. Okay, cross section of the wall. Right. Now, the inside temperature 20 Celsius due to air condition, outside temperature 30 Celsius, normal ambient temperature. It's 5 centimeter wooden layer. And wooden layer thermal conductivity given, it is 2 watt per meter per Kelvin. Wall thermal conductivity given above 4 watt per meter per Kelvin. Per meter per Kelvin. Hi. They are the data given in the diagram. Given in the question. Hi. Now the question asks what is the theta? The intersurface temperature. The contacting surface temperature. Then a contact and surface. If you got this is a wall and this is a wall and this is a wooden place, the intersurface mean the contacting surface, like this, contacting surface. And how to calculate? Very simple. Now, this is our basic equation. Now, in the same question, no need to write down the equation again. Now, I can start. I can directly start. I will zoom out this. Now, equation we previously got. Now, I am going to directly substitute now. Q over T. I'm going to get first into wall. Wall. This is a wall. This is a wall. This is a wood. This is a wood. Wall. First, let's consider about wall. Now, wall. The thermal conductivity 4. I'm writing short form without unit. What's the cross section area? 5 into 2, it is 10. 10 square meter. Multiply. Very important. Temperature difference. Now, what is the temperature difference of wall? 30 minus 20 or 30 minus theta? 20 inside room temperature. Room make atule. Then it is edge of wooden layer. Then what is the temperature difference? 30 minus theta. That's the most important point. 30 minus theta is the temperature difference. 30 minus theta is the temperature difference. Divide by what is the thickness of the wall? Thickness 0.2. 0.2. This is my first equation. Okay, I got this temperature difference. Joel? Temperature difference understood? Then walls දෙකක් තියෙනවා. Therefore, this is the temperature difference and this is my first equation. Okay, I'm going to get thermal conduction rate in the second step for wooden layer. Q over T equal the thermal conductivity of wooden, it is 2. The cross section, not cross section area. Cross section area same now because wall, the entire wall covered this wooden layer, it is 10 into what's the temperature difference now? Okay, difference 20 and theta. Now tell me what is a higher value? 20 minus theta or theta minus 20? 20 minus theta or theta minus 20? Very good. Theta is greater than 20 always. Theta greater than 20, therefore theta minus 20. theta minus 20. You have to careful, more careful. Theta minus 20 divided by, what's the thickness? It is 5 centimeter. If it is 5 centimeter, let's check with question. Is it 5 centimeter? Sorry, it is 1 centimeter. Sorry. 1 centimeter, my mistake. It's 1 centimeter. 1 centimeter. Then 1 centimeter means 0.01 meter. This is my second equation. Now, how about the flowing type? It is steady, right? Steady or continuous. Steady or continuous. Since it is continuous, clearly write down questions. Since continuous, first equation equal to second equation, because both thermal conduction rate, the amount of heat energy enter within unit time, equal to the amount of heat energy leaving out in the same time. Then first equation equal to second equation. Now 4 into 10 into 30 minus theta divided by 0.2 equal to 2 into 10 into 10 into theta minus 20 divided by 0.01. That's the relationship. Then now it is equal. 4 and 2 cancel out into 2. 10 to 10 kohamat cancel. 10 to 10 cancel. 2 into 30 0.2 divided by 0.2. What's the value? Two divided by 0.2. It's cancelled into 10, no? May I cancel 10. It is 1 cancel, sorry, 1 divided by 0.01. It is 100, no? 100. Then it is 1 and 0.01 cancel into 100 for easy calculation. Now 10 into 30, 300 minus 10 theta equal 100 theta minus 100 into 20, 200, 2000. Yeah, 2000. 2000. Now you have to careful. Theta 10 minus 10 theta get into this direction, 2000 get into this side, minus 2000 get into right side. It is 300 plus 2000 equal 110 theta, because 10 theta get into this side. Now 2300 equal 110 theta. Then what's the value of theta? Theta 0 0 cancel. 230 divided by 11. 230 divided by 11. 20.9. 20.9 Celsius. 20.9 Celsius is the intersurface temperature. Okay, do you have any doubt? Salmia? Fatima? Who correct this question? Anyone correct? Dehini correct? Fatima? Tania? Or Harida make? At least if you got 21 Celsius, you are correct. 21 වත් ගත්තනම් approximately. Who correct this? No anyone? Joel? Habib? What happened? Forgot to method. After today, you can't forget. Okay. Now this is the second time we doing same thing. Dihini, what happened? First part only. Kabir, what happened? Tanya? Yeah, this time most probably this double wall questions most probably coming. Therefore, you have to practice. Continuous or steady state mean you can equal this to equal kalla you can get the final intersurface temperature. Intersurface temperature. And you can check your answer. See, you can check your answer. No, inside temperature 20, outside 30. Therefore, always theta temperature should be between 20 and 30. No, if not, you are wrong. Theta වෙන්න ඕනේ ඇත්තටම මේක 1 centimeter 20 වලට ළඟම එකක් වෙන්න ඕන. It should be very close to 20. It is only 1 centimeter wouldn't there. Couldn't be more different value. It should be very close to 20. Now it is approximately 21 centimeter Celsius. It's correct. That we can check. Okay, any doubt? Sarmia, do I need to explain again? Good. Okay, let's move into next part. මේ වගේ එකක් ගොඩක් දුරට එන්න පුළුවන් this time. Double wall conduction questions. Okay, how you can equalize these two equation if this question given steady or continuous word, you can equal and find the intersurface temperature. Right. Final question asks, calculate the new thermal conduction rate of the wall after add wooden layer inside the wall. When we adding the wooden layer, if it is efficient mean AC bill එක අඩු කරගන්න. If it is efficient, what is the requirement to reduce the thermal conduction rate? අපි බලමු අඩු වෙලාද කියලා. We can check. Okay, final question for you. Okay, now this is a wall. This is a wall. This is a wall. This is a wooden layer. This is a wall. It's 20 centimeter. Wooden layer 1 centimeter. 1 centimeter. And the intersurface temperature theta equal 20.9 Celsius. The outside temperature 30, inside temperature 20 Celsius, and the thermal conductivity is 2. Thermal conductivity of wall it is 4. 4 watt per minus per Kelvin. Hi, there are the data. Okay, now how you can calculate the thermal conduction rate? Now, if it is steady or continuous, easily you can calculate the thermal conduction rate of any thermal conduction rate of both walls, wooden layer and wall, it is same. මොකකට ගත්තත් same. Okay, then I can get Q over T equal KA delta T over L. Delta T over L. Okay, I'm going to get into wooden layer. The K value 2, what M minus 1, K minus 1. The cross section area 10 square meter. Temperature difference 20.9 minus 20, it is 0.9. 0.9. If you got length, it is 0.01. Hi, Rambala. Uh, 10 divided by 0.9, it is 9. 9 over 2, 18. 18 divided by 0.01. 1800. 1800 what is the Q over T? What's the previous answer? What's the previous thermal conduction rate without wooden wall? Salmia, without wooden wall, what is the thermal conduction rate? What's the thermal conduction rate without wooden wall? Without wooden wall? That was 2000, right? That was 2000. Now it is only 1800. ඕනනම් අනිත් එකට අරගෙන බැලුවත් same answer. If you got to wall, මේකත් කරලා පෙන්නන්න. If you got into wall, same answer. Q over T, the thermal conductivity 4, 10, cross section area, 30 minus 20.9, 9 minus 1. 9 minus 1. thickness 0.2. Medium-Tharaka men. 9.1, 91 over 4. So 91 into 4 divided by 0.2. 1800, right? Same answer. Same answer. What? Okay. Now, what's the difference? Without wooden bowl, it was 2000 watt, right? It was 2000 watt. But when we use this wooden ball, we can decrease, we can reduce, we can drop the thermal conduction rate by 200 watt. 200 watt. That means 200 joules per second. Understood, Terma? Dehini? Tanya? Tanya? Hari. Let's move into part B. A linear aluminium metal strip in the laboratory. The same question, part B with right. Still, we are discussing about laboratory. 6 centimeter length. 6 centimeter length. When the air conditioner is turned on, the temperature of the metal strip drops from 30 Celsius to 20. That's okay because air conditioner turned on 30 Celsius previously before start the air conditioner, but when it is working, it's dropped up to 20 Celsius. If the linear expansion of the aluminium is 2.5 into 10 to the power minus 5 per Kelvin, calculate the reduction of its length. Reduction means contraction. Contraction. Delta L is asking. Delta L is asking. Delta L is asking. Hi. Now, linear expansion, delta L. I'm not going to explain theory. We already discussed. Delta L equal L1 alpha delta theta. L1 alpha delta theta. L1 alpha delta theta. What's the meaning of the L1? Initial length. It is 6 centimeter. 6 centimeter. Do you want to convert into meter? No. For expansion questions, I think you can remember. Expansion questions, if you substitute answer this initial length L1 by centimeters or millimeters or whatever unit, your answer coming in same unit. Therefore, not compulsory to convert into meters. Onnam convert karat hari, but it is not compulsory. L1, 6 centimeters multiplied by alpha. Alpha means linear expansion coefficient. It is given 2.5 to 10 to the power minus 5. 2.5 into 10 to the power minus 5 per Kelvin. Temperature difference 30 to 20, it is 10 Kelvin. Kelvin to Kelvin per Kelvin cancel out. 6 into 2.5 into 10. Now 10 multiplied by 2.5 is 25. 25 into 6, it is 150. 150 into 10 to the power minus 5 centimeter. 0.0015 centimeters. That's the length reduction. That's the length reduction. Okay, who correct this? They are very simple. Right hand? Make a hurry. A bit. Good. Fatima? Dihini? Harida? Okay. Now, part 2, what is the length of the metal strip at 20 Celsius? Now it is contracting, then decreasing. Now new length is asking L2. No? L2. L2 equal, now it is contracting. Therefore, L1 minus delta L. L1 minus delta. If it is expansion, it is plus delta L. L1, 6 centimeter minus 0.0015 centimeter. What's L2? L2 at 20 Celsius. 6 minus 0.0015. 5.9985. 5.9985 centimeter. 5.9985 centimeter. 5.9985 centimeter. centimeter. Third one. A vessel in a above laboratory contains 2 kilogram of water. Okay. 2 kilogram mean approximate 2 liters. No? Normally 1 kilogram of water equal to 1 liter because the density 1000 kilograms per cubic meter. I think, yeah, fluid mechanism we can discuss. In a vessel in the above laboratory contains 2 kilogram of water. Within instant of time, the water temperature has dropped from 30 Celsius to 20 Celsius. The water, yeah, due to air conditioner, in a particular time, the water temperature drops from 30 to 20, same as aluminium rod. Calculate the amount of heat required to bring the water back to its previous temperature. Calculate the amount of heat needed to bring the water back to its previous temperature. Again, now initial temperature 20 due to air conditioner. I want to get into previous. Previous means 30 Celsius again. The amount of heat asking. Only for water, but see, calculate the amount of heat required to water. Water. Only for water. Don't need for calculate vessel or container. What is the equation? Q equal mc theta. Mass 2 kilogram. Specific heat capacity 4200. J kg minus 1, k minus 1, very simple. Temperature difference 20 to 30, it is 10. Kelvin. Kelvin to Kelvin minus 1 cancel out. Kilogram to kilogram minus 1 cancel out. 2 into 4200, 8400. 8400 into 10, 84,000. 84,000 mean 84 kilojoule. Very simple. 84 kilojoule required. Only for water, without considering the vessel. 84 kilojoule. 84 kilojoule. 84 kilojoules. 84 kilojoules. Okay. 84 kilojoules. Go to next. Final part of B part. How much heat must be supplied to rise the temperature from 20 Celsius to 30 Celsius if this water is kept in a water tank? Heat capacity of heat capacity of copper is 100 joules per Kelvin. 100 joules per Kelvin. How much heat must be supplied to rise in temperature from 20 to 30 if this water contains in a container? It's a good question. It's a good question. Now, the water, 2 kilogram of water included in a container like this. It's a copper container with C, capital C, heat capacity 100 joules per kilogram. 100 joules per kilogram. JkG minus 1. It's contained 2 kilogram of water with specific heat capacity 4200. Kg minus 1, K minus 1. Now the question asks, what is the heat requirement if it is put in a container like this? If it is put in a container like this. What's the method? The amount of heat Q equal water absorbed heat plus container absorbed heat Now water absorbed heat, now you already know it is 84,000. Again, no need to take time for calculate this. Time gonna be. Now container absorbed heat, the heat capacity given, it is C theta. Heat capacity. 84,000 joules plus heat capacity 100 JkG minus 1. Sorry, Jk minus 1. Jk minus 1. Temperature difference 10 Kelvin. Kelvin to Kelvin minus 1 cancel out. 84,000 joules plus 1000 joule. 85,000 joules or 85 kilojoules. 85 kilojoules. 85 kilojoules required if it is contained in a container with heat capacity 100 joules per Kelvin. 100 joules per Kelvin. Hari. Do you have any doubt up to now? We have completed up to B part. Hari. Sarmya? Understood? Tanya? Hari. Let's move into part C. Okay, today we can finish class 8:50 because I have another session at night. Next tomorrow you have special class, no? Tomorrow we are starting at 6 p.m. and you need, I told how many graph papers you need? You have to get 8 graph papers, 8 or 10. The Hackman Garden. 10 graph papers divided into 5 by 5. 5 by 5. Don't get 10 by 10 graph papers. 5 by 5 mean like this. One large box. මේ වගේ box තියෙන්නේ. One box divided into 5 like this. Like this. Make a 10 වලට බෙදපුවක් තියෙනවා. It's little bit difficult to draw and difficult to understand, difficult to find lines. Find this type. Okay. Final part. Okay, final part. 50 gram of ice at minus 10 Celsius was added to the water. This is mixture method. Mixture method. 50 gram of water. Sorry. 50 gram of minus 10 ice was added to the water. Water container mentions at previous part after heating into 30 Celsius. Now this is, understand, this is a water container. Previous question, water container. It has 2 kilogram of water at 30 Celsius now. Okay, 30 Celsius. 10 gram of ice cube 10 gram of ice cube, sorry, 50 gram of ice cube, no? 50 gram of ice cube. 50 gram of ice cube at minus 10 Celsius. Added to this container. Calculate the final temperature of the water of the container, water container, if lost 2 joules. Yeah. 2 joules lost to the environment. 2 joules lost to the environment. Joule දෙකක් lost වෙලා තියෙනවා. When it is mixing. Okay. Do you remember in mixture method? Last week I explained. In mixture method, what's the method? What's the concept? When we preparing any mixture, the high temperature substance releasing heat equal to the low temperature substance absorbing heat if there are no any heat lost. That's only mixture method. I will explain mixture method. This is a theory. Mixture method. Okay, mixture method mean actually the 2 or more factors mixturing. 2 or more different temperature substance mixing process. When it is mixing, what's the thing? If there are no any heat loss, to the environment, heat loss එකක් නැත්නම්, if there are no any heat loss to the environment, low temperature substance high temperature substance absorb heat. Think it is low temperature substance, then we adding high temperature substance here. High temperature substance releasing heat energy. This, if there are no heat lost, high temperature substance release heat perfectly equal to the low temperature substance absorb heat. This is the mixture method. But what happened to if there are any heat released to the environment? That we called as if there is heat lost. Then what to do? High temperature substance release heat. Equal to the low temperature substance absorb heat. Plus heat loss amount. Okay, that's the story. Plus heat loss amount. That's the story. Hi. This is a theory. That's only mixture method. If there are no heat loss, high temperature substance release heat equal to the low temperature substance absorb heat. If there is heat lost, what's the condition? What's the rule? The high temperature substance release heat equal to the low temperature substance absorb heat plus the amount of lost heat amount. Now, according to this question, our final question, there is a heat loss, right? Now, therefore, who is heat releasing? Water or ice? Water, ne? Water is 30 Celsius. Water plus container release heat equal to the ice absorb heat. Water and container release heat because they both water and container at 30 Celsius equal to the ice absorb heat plus for what? Release heat lost. heat loss. Heat loss. Hurry. Now, water container, water plus container release heat. Previously calculated. No need to take time. Sorry. That we can't use. Sorry. Because in mixture in, sorry. Then water release heat mc theta plus container release heat c theta equal ice absorb heat. All ice cube is melting, no? Therefore, what happened? That's important thing. මම බෝඩ් එක අදින්නම් මෙතන හිට මදිය. -10 Celsius ice cube. හරි. What this question asked? Ice specific latent heat also given. Therefore, it's completely melting, no? 2 joule released to the environment. 2 joules released to the environment and ice L value given. L equals 720, right? 720 per Kelvin. 720 per Kelvin. Hurry. Okay, how to do this? As I explained previous, water plus container release heat equal to ice absorb heat plus ice absorb heat plus heat loss. Now water mc theta plus container c theta equal to ice absorb heat. First of all, ice come to 0 Celsius, right? mc theta. Then ice convert into water, ml. Again, it's come to theta temperature, mc theta again. Plus 2 joules loss amount. Hari. මේ බලන්න. mc theta. It is 2 kilogram. 2 kilogram. Specific heat capacity of water 4200. Temperature difference. Water temperature difference. Now I want 30 Celsius to it's come to 30 from 30 Celsius to theta Celsius. Then what happened? It is 30 minus theta. Final greater value minus lower value 30 minus theta. 30 minus theta plus heat capacity 100 temperature difference 30 minus theta 30 minus theta 30 minus theta equal equal the mass of ice cube. It is 50 gram. 50 gram mean 50 over 1000. 50 over 1000. Specific heat capacity 4200. Temperature difference 10 because minus 10 to 0 first. Minus 10 to 0 first. Plus ml. L value given. L value given. 18 over 1000. L value 720. L value 720. L value 720 plus MC theta. MC theta again, mass 18 over 1000. Sorry, not 18, 15. 50 gram, 50 over 1000. 50 over 1000 into specific heat capacity 4200. Temperature difference. Now theta. Yeah, 50 joule. Sorry, mistake. 50 over 1000. Specific heat capacity 4200. Temperature difference theta minus 0, no? Because now it is 0 Celsius. It is come 30 Celsius water to theta Celsius water. 30 Celsius container come to theta Celsius temperature. Now minus 10 first convert into 0. 0 convert into 0 ice, 0 water. 0 water convert into theta water, theta Celsius water. Now theta water, theta minus 0. Theta minus 0. Theta minus 0. Because theta is greater than 0. Theta is greater than 0. That's why I got theta minus 0 plus 2 joules. Plus 2 joules. Plus 2 joules. It's a long calculation. अब मेरे का हदाගෙන යනවා. 8,400 into 30. Minus 8,400 theta plus 100, sorry, 3,000 minus 100 theta equal 30 to 30 cancel out. 42 into 5. 42 into 5. It is 2,100 plus 20 to 20 cancel out. 72 into 5. 72 into 5. 36 because 10 cancel. Plus 30 to 30 cancel. 42 into 5. 210. 210 theta. 210 theta. 210 into 0 again 0 plus 2 joules. 2 joules. This is a calculation. Then what to do? 252,000. හරිද? මේ දිගට තිබ්බට same very simple calculation. Sorry, finally it is plus 2 joules. Plus 2 joules. හරි. Now at these values, at these values, 255,000 minus, it is minus adding 8,400 theta minus 8,400 minus 100. Then what is the value? Minus 8,500 theta equal 2,136. 2,136 plus 2, 38 plus 210 theta. The product simple. Now 2,500 theta get into this side and this value get into this side. 255,000 plus, not plus, minus 2,138. 2,138 equal, 210 theta plus 85,000 theta. $2,862 equal 85,210 theta. 8,500, 210 theta. Okay. Now I want theta, final temperature. Final temperature. Now you can divide. Yeah, the final temperature 2.96 Celsius. Yeah, that's a one calculation. 2.96 Celsius. Let's say 8,500. Yeah. Mistake. I have method 8,500 plus 8,500 theta. Sorry. Then it is 8,500 plus 200, 8,700, 10 theta. Good. එතකොට මොකද වෙන්නේ? මෙතන වැරදි, sorry. Now you can divide. Yeah, 29.03 Celsius. Yeah. Because 30 Celsius water container, we add very small ice cube, no? Very small ice cube, no considerable temperature difference. Sorry, previously I got the wrong one. Yeah, these are value. These are value. Hi. Any doubt? Any doubt? Okay, that's the officially the end of heat lesson. We discussed all theory parts and all type of questions, and we discussed in revision classes. We final 3 days we discussed all parts: thermal expansion, quantity of heat. Today we completely discussed about thermal transformation as well. Okay, next you can ready for the exam next Tuesday, and you will have area volume special session on Friday. It's only 2 hours. Friday 2 hours. You have area volume to discuss this question, the remain question. You can ready. Okay, this is a question. This is a question. This question, and I hope to give you another past paper question. And tomorrow you can ready for your final statistic question. You need 10 graph papers, and I will and we starting at 6 p.m. to 10 p.m. You have 4 hour session. I will give you break 10 minutes, 20 or 15-minute breaks after 2 hours, and we can continue. And I hope to discuss all part of frequency tables, frequency curves, frequency tables and frequency curves, cumulative frequency table and cumulative frequency curves, histogram and frequency polygon, and finally percentage cumulative frequency table and percentage cumulative frequency curve, and how to answer questions using these curves and tables. Okay, do you have any doubt from today part, Mandala? Do you have any doubt? Any doubt? Joel, Samia, Tanya, any doubt today part? Didi? Please again go through one time heat lesson. I'm a definitions revise karan again doing this. This is final 100 days. Okay, then let's meet tomorrow 6 p.m. Remember to get draft papers. Goodbye.